Hey guys, it's Mr. Rysz here. I'm gonna put on my glasses. We are gonna start Algebra 2 on our first lesson here. So we're gonna start with 1-1. Now 1-1 is a really simple section. And what you'll notice here is the notes. I'm not gonna break it into two parts. I'm gonna try to go through all the notes at once. We'll see how this goes. Although that we will spend 2 days on this section, I'm gonna try to get all of it done in one notes, and then you'll have like kind of 2 days worth of work. So let me screen share the notes with you. Now, hopefully you guys have downloaded these notes and you have them printed off, or you grabbed a printed off copy of them. These notes are always really good to go over, help you out with the thing. I'm going to be using this pen here. It's new, so I might have some technical issues, but there we go. So we're going to start here with the I cans. So what you want to make sure is you can interpret, there we go, the key features of linear, quadratic, and absolute value functions of a given equation or graph. So we'll do a little warm up here in this activity. We're going to look at a diver is going through the ocean in a search and rescue training. The graph shows the relationship between her depth and the time in seconds starting her dive. So as time goes on, she starts 0 seconds above the water, which makes sense. And then she jumps in after 1 second, she's touching the surface, and she goes down. 5 seconds, she's at -8 feet, and then 9 seconds back up to the surface. Ooh, I hear some thunder. All right, so if you want to write these in, you can. I'm going to try to do my best. Is there part D? No. We'll pull this up here and we'll get this started. All right, so what details can you determine about the coordinates at 5, -8? So there's a lot of different things we could write here. We could put, I'm going to put like at 5 seconds, at 5 seconds. That's the lowest point. So at 5 seconds, she's at low. At 5 seconds, she's at the low, or equals a low of 8 feet below. Okay, what is the average speed of the diver in the water? Okay, well, let's see here. The way we can figure out speed is to calculate the distance over time. So if you think about it here, we know, right? I'm going to try to change my color here. Ooh, technical difficulties. Speed is distance over time. Well, she goes down 8 feet and back up, so that's a distance of 16 feet. Over time, well, let's see, it says in the water. Well, she starts the water at 1 second, gets out at 9 seconds, so that's a time length of 8 seconds in. So 16 feet over 8 seconds, so that would be 2 feet per second. Okay, what point of the graph, change my color here, a little purple. What point of the graph shows the starting location of the diver? Well, I would say the starting location is here at 0, 2. And explain? Well, we can say she starts above the water. Right? She starts above the water, 2 feet. Okay, what does the V-shape graph tell you about the dive? What information does it not tell you about the dive? Okay, so all we know here, the V-shape tells us she's going down, then up. Okay, so we can say I'm right here. Okay, this is gonna be just a little awkward here. She goes down, then straight up. I'm just abbreviating here. What we don't know, you know, it looks visually like she's going down. She jumps off the boat like, woo, and I'm gonna go down, then over. Well, all we know is depth. We don't know how far away from the boat. So we would literally get the same graph if she went down 8 feet, right below, and then came back up. Or if she went like just a little bit down and then up, or if she went down and then went really far over, like just went Aquaman fast, but only went up 8 feet. Yeah, we don't know. Does she goes, no, just go left or right. All right. So that's a little warmer. We're just looking at this graph, trying to get some information. So hopefully your brain's working now. You're ready to interpret more graphs. Okay, next. Here we go. We're going to look at domain and range here. So what are the domain and range function of the equation y equals x squared minus 3? So first off, we have a couple of vocab words here. The set of possible inputs for the relationship is the domain. We might want to make a note here. Domain is the x values. Oh, there we go, spell them correctly. You can square any real number, so there's no number we wouldn't be able to put in here. So there we go. It will work. The range right here is the outputs. The range is the y value. So the way I always look at it, if I'm looking at a graph, our x values are how far over left and right does the graph go. Now this graph, the arrows that say this graph would keep going over to the left, it would keep going over to the right. Now it would take a long time, but it would keep going. The y values are your up and down. Well, we know this graph would keep going up, but there is a low point here. So there would be a minimum. So the way we would describe this domain in this graph here is we're going to use set builder notation. Okay, that's probably the easiest and quickest way to do it. Now the domain goes from negative infinity to positive infinity, because negative infinity would be the lowest number all the way over to the side here of what we could mark. Positive infinity would be the biggest number we could mark. Now the range, we know the range is going to go all the way up towards infinity, right? That graph goes all the way up towards infinity. There we go. So it would end at infinity, but there is a low here, and this low is at -3. Now what we're going to do is actually put -3 in a hard bracket there, a squared off bracket, because we do include it. Now if -3, if there was like an open dot, we'd put a rounded bracket. I'm not going to be too worried about that. I don't think there's going to be any questions that you guys will see where you'll have to nitpick the difference between an open and closed, but that's something we're going to make sure we practice on doing correctly. Okay, let's keep this going here. So there's different ways to use set builder notation. I like doing interval notation. In fact, we're going to skip all of set builder notation here. It's one of those things, because of this year, we're going to just cancel it out. So if you see it, it means the same thing. So from like -3 to 4, include those. But if I have the rounded bracket, we don't include those. So I think the interval notation is just a whole lot easier to use. Okay, so let's look at this one here. Let's write the domain and range of this. Now, honestly, finding the domain and range, just looking at the function, is a bit difficult. Like, it's hard to do without knowing what the graph looks like. So I would recommend getting out Desmos or your graphing calculator and doing that. So let's see, I'm going to do a new share here. I can do my screen. I think this is what I can do here. That's CYU. Let's put up Desmos here. Let's split screen this, and I'm going to just double check that that's what you guys see. You see both of them. All right, let's go to the graphing calculator. Let's first graph this. Y equals, now to get the absolute value sign here, I'm going to go down here, click functions, and there should be maybe in the miscellaneous. No. Where is this absolute value? Here, boy. Oh, actually, it's not over there. It is right here. X minus 4. Okay, so now that we got this, we can look at this graph a whole lot easier. So domain, I would say, is the exact same thing in the other one. So I'm just going to put DNR here. Ooh, I want my pen. So the domain, negative infinity to positive infinity. It goes all the way to the left. It goes all the way to the right. The range, though, does have a low and a high. We have a low point here, which is at not at 4. We're looking at up and down. The lowest it goes is 0. And we do include that. The highest it goes, well, it could keep going up forever, to infinity. Okay. Dang, I wish I could just do that here. All right, so pause the video if you need to write that down, but I'm gonna have to delete it so I can get to the next graph. All right, next we got y equals 6x minus 2x squared. Okay. I wonder if you guys can hear that thunder. Sounds pretty fun. I don't think I'm going on my run today. All right, so the domain. Hey, look at this. This will be a common thing too, especially when we're dealing with first functions. We're going to keep it simple. Domain. This graph would keep going to the left eventually and would keep going to the right. We could zoom out if we wanted to, but negative infinity to positive infinity is the domain. The range. Well, let's look at this one here. This one has a max of that 4.5. Yeah, it'd be 4.5. Did I type that in right? And then it would go all, so the lowest it goes is negative infinity. But we do have a maximum now of 4.5. Oh, I did the wrong bracket. All right, it does include that 0.4.5%. Over, God, that'd be tough to figure out without a graphing calculator. Ooh, try that again. I'm staring at the wrong thing. I gotta use this pen here. Boop, boop, boop. Yeah, good enough. So it's that hard bracket there. Okay. So there's domain and range real quick. All right, let's go back to full screen these notes up here. Keep going. All right, X and Y intercepts. So this would be the next point. So X and Y intercepts are your starting and location for the Y intercept, typically in a story problem. And your X intercept is where the graph crosses the left and right line. So we got a little another warm-up activity here. A car starts on the journey. Okay. Can't really have them both, so I'll just list them here. All right, starts on a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates to the number of gallons of gas, y, left in the tank to the number of miles traveled by x, where x and what are the x and y intercepts of the graph and what do they represent? So let's first see the x-intercept. The x-intercept is right here on the, where does it cross the, actually, no, it's not. The x-intercept is, sorry, calculus, we did y first. Get my brain mixed up. The x-intercept is over here. So the x-intercept is, we'll say, is at 320. And let's just do, for the sake of it, over here, the y-intercept. So you can see both of them. Ooh. The y-intercept is at the point 16, 0. Oh, geez. Not 16, 0. The y-intercept is 16. But we want to have it at, oh man. Good morning. 0, 16. All right. So hopefully you guys can see that x-intercept, this is review from like Algebra 1, even in geometry. Where does it cross the x-axis? It crosses right there at 320, 0. The y-intercept, where's that point located? Over 0, up 16. Now, what does that mean to our story problem? I think y-intercept's the easiest one to figure out. Remember, x represents the miles we traveled. Y represents the gallons that are in the car. Well, that means if we travel 0 miles, we would have 16 gallons. Or we could just say from there, okay, we start with 16 gallons. Now, what does 320 mean? Well, 320 is miles, 0 is gallons in the car. All right, so if we don't have any gallons in the car, we got 320 miles, so we can go 320 miles on a full tank. I'm assuming they filled the tank up all the way. All right, so nice little warm up there to help us think about X and Y intercepts and how do they relate. Now, how do we go through this? So if we ever want to find X and Y intercepts, we can graph it. Totally fine to do. So if you want to use Desmos for this to look at your X and Y intercepts, do that. The other way to do that is to do it analytically. So if I want to find the x-intercept, The key thing to remember, the x-intercept is going to be at the point something, comma, 0. So that means the y equals 0. So what we're going to do mathematically here is to make the y equals 0 and solve for x. Ooh, that should be a minus. Okay, so if we want to solve this, let's get the absolute value over. So when does 3 equal the absolute value of x? So what number, when we put it in the absolute value sign, does it equal 3? Well, definitely 3 does. And that's not the only one, though. Is -3 works as well. So we would actually have two x-intercepts. Maybe we'll double check this one on Desmos when we're done here, of -3 and +3. Now the y-intercept is always a lot easier. Y-intercept is always at 0 comma something. So when does the x equal 0, what do we get for y? So when y equals the absolute value of 0 minus 3, absolute value of 0 is 0. What's 0 minus 3? -3, and that's the only possible answer. So let's actually graph this one to double check here. Double check our work. We have 3, 0, -3, 0, and then 0, -3. All right, so let's go to Desmos. Can you guys see that? Yep. All right. We got the absolute value of x minus 3. And just click on these. Where does it cross the x-axis? -3, 0, and +3, 0. Where does it cross the y? 0, -3. Yeah, we're pretty smart. Guys, remember when you watch these videos, if you want to go back and rewind to go over these concepts, feel free to do that. Hopefully they're not too bad. Okay, next one, what's the x and y intercepts of this? Well, we could do the same thing, just type it into Desmos. But if you want to try this one on your own, feel free, pause the video. But I'm going to keep going through. Okay, here we go. X-intercept. We're going to make the y equal to 0. Now remember, g of x is the same thing as y. All right, so it would be 0 equals 4 minus x squared. All right, I'm going to move the x squared over to the other side because I always like having positive x's. So x squared equals 4. So what number squared does it equal 4? Well, that would be 2, but actually not just 2, positive and -2. So we would have -2, 0 as our x-intercept and a +2, 0 as our x-intercept. Now the y-intercept, easier to figure out. We just make the y equal to, oh no, we make the x equal to 0. And solve for that. Well, here we go. Takes you about 2 seconds here. 0 squared 0, 4 minus 0 is 4. So we'd have a y-intercept at 0, x, 4 for y. Hopefully you did all right. And double check on Desmos. Okay. So this would be a good time to pause the video if you need a break, take it. But I'm going to keep going through recording these videos, see if the longer one works out all right. Maybe I could always timestamp these videos too on YouTube. We'll see how this goes. The next point are these positive and negative intervals. So the positive and negative intervals is where the graph is above the line or below it. So if we look at this graph here, this graph is above the line from everything from -3 to the left, and it's above the line from +3 to the right. So we would say that's positive. And if we're going to use interval notation, we would say from -infinity all the way up to 3. Now, the actual point 3 is at 0. 0 is neither positive or negative, so we're not going to use a hard bracket. And then we can say and. I like to just use that symbol. Some people use like a union symbol. It don't matter. We're just going to put it 1. Then from -3 or from +3 to infinity, it's also positive above the graph. Okay, now what is below the graph? What is negative? Negative is where we have all our y values are less than 0. So that's where everything is below the x-axis, and that's in between 3 and 3, or -3 and 3. Oh, I did see a mistake I made. Right here, that should be a -3. All right, so our negative, we're below the x-axis from -3 to +3. And that's the only point there. That's the only set we would have. And those would also be open brackets because those points, -3 and +3, are at 0, which doesn't have a value. Okay, so let's keep that concept going here as we move on. So let's look at the equation here. At h of x, let's just call that y. Y equals 2x plus 10. So where is it positive? Where is it negative? If you want, I think it'd probably be easier to graph this. So I'm going to take out Desmos. I think it's still okay. I think you guys can see that here. I'm just going to type in y equals 2x plus 10. Okay, so remember, positive and negative values is where it crosses the x-axis. So, okay, move that a little bit. So it seems like right here, the only time it crosses the x-axis is at 5 or -5. So if we're going to talk about positive, it is positive from -5 all the way over to infinity. So -5 is the lowest time it is positive. And then everything on to the right, all the way up towards infinity and beyond Buzz Lightyear, it stays above the line. Now, negative is where is it below the line? Well, the lowest, remember, this is always kind of weird to think about, but the lowest number is -infinity. So let's write that out. So from -infinity, it's below the line, and it stays below the line until we get up to -5. All right. So hopefully that kind of clears some things up. The next one, a lot of people get these confused because now we're going to be looking at direction and not so much where its location is at. So we might have to draw a little bit more on. So increasing or decreasing functions. Increasing functions and decreasing functions is where the graph is going up in direction and where is it going down. Is that mine? All right, so if we have this graph here, we want to make a table where it goes up or down. So we are not looking at to see where is it above or below the x-axis. We are looking to see direction. Where is it going up versus where is it going down? And right here at 0 is the changing point. So we would say that this is increasing. I'm just going to put big here. From -infinity all the way up to 0 is where we get the change. So from -infinity to 0, we are increasing. And then we can say it's decreasing. Well, it decreases from 0 all the way over to infinity. There you go. So that's how we'd write it in interval notation. So we got these two problems here, and this is actually where we end. We're going to skip this average rate of change. This is one of the things we're kind of cutting out the fat here. This will be something we talk about later. Kind of, I think it's confusing to toss to you right now. I think there might be a problem or two on your homework, but I just made them with 0 points. So if you guess it, get it right, awesome. If you don't, it won't hurt you. All right, we got these two problems here. We're going to figure out where they are increasing or decreasing. And I'm going to split screen this here because I think Desmos is going to be our friend when it comes to this. Can I put them both on the screen here? I think I can. All right, I'm going to look at, well, let's see if I can look at both the graphs at the same time. So we got y equals x squared, that is not, minus 4x. And then we got y equals negative 2x minus 3. Okay, that's a blue line there. All right, so red is A, blue is B. If you're colorblind, I apologize. Red is the curved parabola, B is the straight line. So let's stop this here, and I will start out with A. So I always like to see, all right, where's the change in direction? So this change in direction is coming in just this curved parabola right here at 2. Now, in calculus, we always go left to right. We don't start with positive and negative or increasing or decreasing. We just describe what's going on left to right. So I always kind of get confused here, but I will do my best. If we want to know when is this increasing, it is increasing from 2 all the way on. So from 2 to infinity, this is going up. That's how we write our interval, from 2 to infinity. Now, when is this graph going down? It's going down all the way, starting at negative infinity, all the way till we get to 2. It's going down. All right, so we would write that as from negative infinity to 2. And that's it. This graph goes in 2 directions. It goes down, then up, and that's why we only have 2 solution points, which is actually a good way to think about it. The amount of directions you have would be the amount of solutions. So if you had a graph that went up and then down and then back up, we would actually have 3 parts because we would have 2 times right here and right here where it increases and only 1 time where it decreases, which actually brings us to the next problem. We look at this, B, the negative 2x minus 3, that is just a straight, I'm just erasing this old stuff here, straight line going down the entire time. So is this line ever increasing? Nope. I'm just going to put no solution there. There's no time it's increasing. When is it decreasing? The whole time it's decreasing. So that would be from negative infinity to positive infinity. Now, hate to get really particular here. If you think a graph never has increasing, there's no guarantee that it's negative infinity to infinity. So one thing in calculus, we go over this, you could have a point that could be increasing like this, and then have a point where it's flat, and then keep going up again. That point where it's flat right there is not increasing or decreasing, so you would actually have to break this up into 2 increasing points where you'd say right there at that one point, it's not doing either. Well, that's nitpicking. Okay, so that was all of lesson 1. And we will spend 2 days on lesson 1 just because we're taking our time with this. We're also trimming the fat, and I don't know how well you guys are going to go through this. So one thing at the end of the notes, there's always these key features. I'm just going to print off the notes from last year. So you're going to have this extra stuff that you guys won't need here. Don't worry about it. But here's some key features to look at, and they help you with domain and ranges if you're looking and you don't know. So always go back to it. You guys will have 2 assignments. You'll have CYU 1 and 2. So this will be your Tuesday and Wednesday assignments. I don't think there'll need to be a need to have a separate video for Wednesday. You can just watch this one over again if you need to, or you can reach out either in class or so. If you're here on Tuesday, we'll make sure you guys are notes and you're ready prepared to do Wednesday all on your own. If you weren't here on Tuesday, hopefully you watched this video and you can come into class on Wednesday with some questions. All right, guys, have a great day. We'll see you next time.